This is a dihybrid cross for blood typing and Rhesus factor. A man who is blood type AB marries a female who is homozygous for blood type A. Both individuals are heterozygous for the Rh factor. Recall that Rh positive is dominant to Rh negative blood type. So we're going to use capital R as our allele for Rh positive and lowercase r to represent Rh negative blood. And that is our legend. Next, we will write the genotype for the man. He is blood type AB, so he's going to have an IA, IB in his genotype, along with a capital R and a lowercase r, because he is heterozygous for the Rh factor. The female is homozygous for blood type A. Homozygous means two of the same alleles, so she has IA, and she too is heterozygous for the Rh factor. So she has big R, little r. Next, let's get the gametes. First gamete for the male is IA capital R. Second one is IA little r. Next, the inner two is IB capital R. And then the last two, IB little r. Because they are all unique, we're going to keep all of those to put into our Punnett square. Female's first gamete is IA capital R. Second gamete is IA lowercase r. Third gamete is IA capital R. And finally, IA little r. Because two of those are repeats, we're going to cross them out. We're only going to use the unique gametes in the Punnett square. Let's put the male's gametes across the top of our Punnett square. So we have IA capital R, IA little r, IB capital R, and IB little r. For the female, we'll put her gametes along the side of the Punnett square. So she has an IA capital R and IA little r. Next, we will fill in the genotypes. Remember to keep the genes that are the same together. So IA, capital R, capital R. Next one, IA, big R, little r. IB, big R, IB, big R, little r. Next row, we have IA, big R, little r. IA, two little r's. IB, big R, little r. And IB, two little r's. Because we are asked to find the phenotypic ratios for the offspring, we're going to look at all of the ones that code for the same phenotype. So I'm going to start with A positive blood. So we have three of those, 3 A positive. Next, we have 1 A negative. We have 3 AB positive. And 1 AB negative. Part B asks, what is the probability that this couple will produce a daughter who will have A positive blood? So from our previous question, we know that 3 out of 8 have A positive blood. The chance of them having a daughter is 1 out of 2. So we multiply that together to get 3 out of 16, or 0.1875. Now we want to record our answer as a value between 1 and 0 to 2 decimal places, so it is 0.19.